TensorRT LLM was so helpful for us to cut our latency by like up to 70%. How can you run the least number of GPUs needed to serve the traffic you have?
How did you deal with the cold start time?
A few things. So first of all, we start using I'm not an AI person initially, right? Like 6 years ago, I had no idea what is all of this about. And then, I was leading engineering teams and I got my scope going bigger and bigger. And then I was like, I need to be in AI. I need to be in machine learning. I need to get there. So I start, picking up and managing teams. I joined a company that is an AI company doing machine learning, traditional reinforcement learning. And I start learning from my team. I was like, hey, junior machine learning engineer, how does this work? And again, it's a little bit of, being humble, but also being hungry to learn. And then from there, it's like it turns into a passion of learning and growing. And with Gen AI became like just the perfect timing of, and I really see the future as like all these senior VPs, CTOs, the classical traditional, CTOs now getting into AI. So that is shifting. Like if you just did everything else except AI, now is not the time to be competitive in the market. So I was, not only following my passion, but also adapting with the market, because I think that's it's going to be a big shift in how we lead engineering teams.
Yeah.
I couldn't just stay on the sideline watching what AI is what's happening in AI. I had to build AI, I had to lead AI, and I had to learn. First of all, I had to learn AI alongside my team. So I came up with this framework of like learning, instead of being very directive and like being the boss and, hey guys, we need to build an MCP server, we need to do this, we need to do RAG, we need to even learn the basics. I go and start learning and ask them to learn with me. Because again, one of the problems we have seen since Gen AI is that like you don't have all the resources, you don't have all the AI engineers available. Like some of these engineering leaders like myself, we are in positions where we're asked to do AI without the AI resources available. And with no previous team or experience building AI. So learning was number one. And then how would you be successful at building AI in enterprise production? So how do you take all of these great proof of concepts and all the hype around like, oh, I can do this, you can do that. Oh, look, I built a chatbot. You can do everything in the platform, just an MCP and a chatbot. But how do you take that to scale? Another topic that could be very interesting is, and you might know this, is building AI in-house, hosting, self-hosting, self-managing AI, not leaning on all of these third-party available API-based AI. Now you need to manage your own GPU, choose a GPU, choose the architecture, choose the open source models, optimize, fine-tune, optimize, distill. I mean, optimize late. I mean, this is what I was more talking about recently, is how you manage what I ended up calling the AI Iceberg of like AI is great and you can do all of this, but behind it, if you want to build it internally and if you manage it at scale, all of these invisible things that performance, latency, throughput, accuracy, quality of the responses, and cost. I mean, one of the other things that was taking so much time for me recently is like how I manage cost of AI, so I can prove to leadership, to the board, to the investors, and to the market that you can build AI at a positive ROI. And how can you retain your customers and gain more by just building AI that doesn't break your wallet? So yeah, this kind of pyramid of cost, performance, latency, and throughput was my focus. And where can you move needles? You can never have all of them optimized. So what is the what I find out being called like an AI nexus? Where is that spot? What it works really well for your use case. It might not work for other use cases, but for our use case, being an HR tech, focus on privacy, responsible AI, performance and latency are needed, but not the top priority. But efficiency and accuracy of the results, and also cost. So finding that right spot and build AI towards that.
There's a really interesting thread to pull there with cost, because you have the cost of AI for your company.
Yeah.
But then there's the cost of AI using AI coding agents and for the engineers. So it's almost like how we're implementing AI with the company, whether it's internally facing or externally facing, you're trying to optimize that and then also prove to leadership that there's ROI. And then there's like this whole other vector of AI that's going and being very expensive in its own right of agentic engineering.
Yeah, exactly.
And the coding agents paradigm. And so
and the premium tokens. And I mean, we introduced a few solutions, and then they worked for some time, and then GitHub Copilot as an example, like you have a bunch of models available, but then you start seeing more and more premium models, and then some of them, their tokens will be 10 times more expensive than regular tokens. So at some point, within engineering, we had a finance kind of role within engineering that was taken care of. Is like ensuring everything goes within the allowed budget, because otherwise, if you open the door to everything, it's just going to blow up the consumptions and tokens and premium stuff. So I had to keep that in control with the AWS builds and all the AI GPUs, because we are deploying models on the GPUs, and so I had to work on scaling as an example. So how can you run the least number of GPUs needed to serve the traffic you have? So understanding the pattern of traffics, like as an example, we are an HR tech solution, so people don't use it at night and weekends most of the time. So why do I have like that many GPUs running at that time?
So we had serverless.
So we had to create first a scheduled scaling for our solutions based on the pattern we see on usage. And then we had to also introduce dynamic scaling, where if you have at the end of the year or at the end of the quarter, or even at the end of the week, sometimes people go and try to push as many, HR data like feedbacks and conversations and recognitions. So you had to take that into account as well. So you had to dynamically adapt and spin up GPUs fast. If you use OpenAI, you don't have to worry about any of this. But then for me, I was like, okay, well, we need to spin up things, and they're containerized, and we need the images. But when you spin up a new container, you need to download the model, put in there. And I was like,
takes forever.
I had to talk to AWS. How can we make this faster? Should I go with SageMaker or solutions like that is managed?
Or just hit Bedrock.
Or hit Bedrock, which is, again, many layers. I mean, if you remember this, I came up with these layers. I mean, they are known like model as a service, software as a service, AI as a service, and then at the bottom there was nothing as a service. And honestly, that's what we're doing. We're trying to do everything.
Hard mode.
And when I had the conversation with AWS SageMaker experts from AWS, they were like, "You guys doing exactly what we do for SageMaker behind the scenes." So you can hop on SageMaker, you lose control some of the configurations, but you will have this given for you. And because our, again, scale and usage is limited, we were able to do some of that in-house without having to rely on a managed service. So dynamic scaling, scheduled scaling, and kind of proactive scaling sometimes.
How did you deal with the cold start time?
A few things. So first of all, we start using faster IO operation storage from AWS, which is FSX. This is kind of new to me too. I was like, give me the fastest way to download a file from your systems. And I learned about this. Historically, we used to get this from S3. So that's one, downloading faster. And then the second thing was, instead of spinning up the image, the container image, and then downloading the model, we created an image with the model embedded in it already.
You baked it in.
Yeah. So when you spin up a new Kubernetes node, it's going to come with the image. So we saved so many, in the minutes, not just in seconds. So we saved minutes of the cold start to just spin up new.
But the GPU itself takes a while, right?
Yeah, the GPU. That time we cannot do much about it. But the downloading part was the trigger.
Yeah, but I'm just thinking because there's certain providers, GPU providers, that go hard on, hey, we can spin up in seconds type thing. I'm thinking like Modal or others.
There was another one, yeah.
Yeah, there's another one. I can't remember now.
It's not Croc.
Yeah, they need to do more. They need to do better marketing so that they stay in our head.
There's one that is like known to be the fastest kind of cold start. It's like you want the new GPU. Here you go. I wish I was able to get like really breakdown of the latency, how much time it takes, and understand, okay, this is for every step. We focus on the ones that used to take the most, and definitely downloading the models, running, spinning up a new node was taking the most.
So that's where you saw the biggest gain.
Yeah, another thing we did, this is maybe not necessarily related to that cold start, but optimizing using NVIDIA tools, solution like TensorRT LLM was so helpful for us to cut our latency by like up to 70%.
What?
On the same, because, you're familiar with TensorRT?
No.
So what TensorRT LLM does is it's going to rewire your model in terms of like the neural network to be adapted to the architecture of the hardware. So you define, you tell it, okay, I'm going to use NVIDIA, whatever,
H100,
A100, whatever. So it knows the architecture. It takes whatever model like Llama 3, Llama 4, whatever, and it's going to tweak it to just fit for that architecture, optimize it. We saved at least 50% latency.
Wow.
That was like again, that's what I told you about the throughput, latency, cost, and performance and accuracy. Like we have been saving cost and saving on latency and saving on cold starts. And also when you use TensorRT LLM and we use specific models from models and GPUs, you get more batching capabilities now. I mean, the first time why my learning has been evolving so much is the first time I was learning about how you deploy a model into the GPU, I was like, okay, we use like, let's say an 8B model. You need a 16 giga to have it there. Okay, so why do I need to have like a 24, or why it's taken so much kind of a gig? If you take an 8B quantized to kind of 4 bits, it takes 4 gig of memory. So when we were thinking of picking which NVIDIA model or any GPU will work best for us, I was trying to get the smaller one where I can fit that kind of 4 gig or 8 gig.
Yeah, you fit it nice and tight.
Yeah, you fit it there and it's all good and it's all
But that
beautiful.
didn't work.
But then I was, as my learning was evolving, I was like, and I was even thinking of fitting 2 models in the same GPU to try to create throughput.
Yeah.
So if I have 2 models running on the same GPU, I can maybe send twice more requests. But then what I ended up learning is like the way the KV cache work and all of these things. It's like you get your model deployed, and then you use the rest for your KV cache. And with the KV cache, you can do batching. And with TensorRT LLM, as an example, you can do in-flight batching. So meaning when you create your batch of like, say, 16 requests, 14 are processing, 2 are done. You don't need to wait for these 14 to be done to create a new batch. You can have 2 more added to that same batch. So it keeps going forever. Again, this is where when I talked about the learning aspect of this and like all the tools available and not be overwhelmed and focus on optimizing one area at a time, I was like, yeah, instead of trying to do 2 or 3 models in one GPU, I'm going to do one model on the same GPU and use everything else for KV cache, and I'm going to have a huge throughput. While again, with optimizing with TensorRT LLM, you will also reduce latency. So I was like, wow, okay, I don't need to go crazy on trying to fit as much as I can within the GPU. Just use the memory. It's kind of counterintuitive to how would you think about regular CPU and memory. You try to fit, okay, if my system will only use this much, I can do more virtual systems running on the same hardware. For GPU and AI, I was like, no. Everything I have left, if I can change the number of, how big is my batch, and I use all the remaining memory left on the video memory, well, we're going to have a lot of throughput. So, and with in-flight, it's going to even be better and faster.
And did you figure out any ideas around the amount of money you're spending? Because if you get more throughput, it enables you to get a bigger machine.
Yeah.
Right?
And yeah. So we increased the GPUs. Obviously, we went from smaller ones to bigger ones. I don't have the exact names. By going to bigger GPUs and having one model, increasing the KV cache, improving throughput, I didn't need to run more of these machines. So this is again another counterintuitive approach. So I have my DevOps infra team coming to me and saying, okay, it's better for us to go and get reserved instances from AWS to pay 30%, 40% less. But reserved instances, you need to commit to a certain number of years.
Yeah.
And then in terms of the GPU, we were trying to get the smaller GPU that gets there and serve us the best. But then every time you pick a GPU, there is a better GPU, right? Faster, better, more memory, but more expensive. And my thinking was, if I can achieve a higher latency, obviously everything will get done and leave the GPU, so I have time to get more things done. And if I increase my throughput, so the number of lanes I can get AI to be running, well, I will be able to serve more customers faster.
Yeah.
So I don't need that many GPUs. So what happened is I did some math of, if I'm going to go from this GPU to the next GPU, it's going to be 30% more expensive, but I'm going to use it 50% less of the time.
That's it.
So it's going to be like 30% cheaper. So we were upgrading on a frequent basis, upgrading GPUs while saving money. So talking about the scheduled scaling I had, I'm going to take some random numbers. Let's say when we start the AI, we were running, again, 10 GPUs for the whole day. And then we looked at this and we said, in the morning and at nights and weekends, we don't have that. So let's do 5 on these times 10 throughout the workday, like from 8 in the morning to like 6 p.m. We will have 10 machines. So I was just by doing that, and I was doing the math, how many GPUs I'm saving, what's the cost per hour. I was always reporting on these numbers. This is how much I'm saving on a daily and weekly and monthly basis. And then now, from instead of having 5 and 10, because I have better GPUs, faster, high throughput with the optimization using TensorRT LLM, I don't need to have 5 in the week, and 2 are good enough to serve. Mm-hmm. And throughout the day, I don't need 10, 6 are good enough. Mm-hmm. And add to that like multi-region. So we also have Europe regions and stuff. And these kind of same strategies work, but for different numbers because of the traffic and the load you have. So over time, this is what, when reflecting on it now, I feel like I was never able to do this. I was able to save money. I was able to improve performance, latency, and throughput, and even quality because I was using bigger models on bigger GPUs. I was kind of optimizing all what I was describing in the pyramid, all the edges of the pyramid every time by learning and exploring all these techniques and technologies. And again, I don't have like an infinite budget to hire the best people who know about all of this and bring them. I was doing this iteratively with my team, getting into, talking to AWS, talking to NVIDIA, understanding, what tools we have available to go and optimize one of each at a time. Yeah, but it's been working. It's been magic. I don't think I've ever done this for any sort of like cloud distributed systems before, where you can optimize all of this. There's a trade-off. Like you want more power. Well, sorry, it's going to be more expensive. You want something else. You're going to trade off something in AI. And I understand it's still like there's a lot of trade-offs to do, but if you do them while focus on your use case and what you need, there was a way to optimize on many levels.
Yeah, you're walking a tightrope.
Yeah.
And you recognize that if XYZ remains true, then that allows us to get a beefier machine to have things get done faster. And especially when we have higher demand, we're going to really take advantage of it. And then we can scale down and take advantage of like the lower demand. So we don't need these machines. And because you're saving money, that probably gives you more expendable cash to test bigger machines and see, does this scaling law, your own little world scaling law?
It was, again, that is exactly what was going on. When I was talking to my team, and my team, I think we all experienced this maybe for the first time, but my DevOps infra SRE team were like, hey, like if you go bigger machines, you're going to pay more. They are like 30, 40% more expensive. And when I was thinking about this, I was like, yes, I want the more expensive thing because I'm going to run it less number of hours. Mm-hmm. My unit is not locked into how much is the cost of the machine per hour. It's how much I'm going to run these machines overall. And we pay per the minute or maybe even by the second.
Yeah.
So as long as you spin them up and turn them off as soon as you're done, and you have this dynamic scaling that really minimize, and you have also the scheduled one, you can run the fewest number of hours using higher GPUs to serve more customers over time. And you're saving time and you're improving latency. All of this also, the other thing we didn't talk about is the models themselves. So we have been also able to upgrade our models to bigger models, better ones. And I'm not even talking about our explorations on using different models now, because for the different use cases, I have use cases where it's more about rephrasing, polishing text. I'm trying to give you feedback, work together in HR tech. I'm going to give you feedback, and there is an agent that will help you rephrase and polish this to be, fit, polite and nice and actionable.
HR compliant.
Actionable and insightful. That's what we say. So that is, we're going deep into the weeds here. And this is just experimentation, but if it's based on just rephrasing, your input and output are small or are about the same size, right? So understanding that and understanding how pre-filling and decoding work, you can think about like, maybe I can use a smaller GPU to just do this and do it faster, because it's kind of the same input and output size. But there are other features where you go and generate the whole program plan. And for that, it's maybe short instruction, but the output is big. So it seems like the pre-filling phase is very quick, very small. But it's all about decoding. It's all about generating new tokens to just, the new data. So maybe there's a different architecture, different models, different GPUs. If you do also load balancing that is based on this information, you can go to the GPUs that did the pre-fill phase the same, because at the end of the day, most of the prompt or the instructions are the same. Go and generate for me a plan for a manager that is this XYZ. It's the main difference is in the decoding part. So some of these GPUs might have, if you design properly, might be capable of saving a lot on the pre-filling phase and go straight into like the first token, start generating immediately. Again, these are next level things that I'm looking into. And there I can go into, again, for some use case, I can go to smaller GPUs, smaller models, and other use case, I can go bigger ones. So now I think the next phase is that kind of layer of routing and proxy gateway. Yeah, we built something, we called it the LLM proxy, which is like an AI gateway.
Yeah.
Decide where to go, which GPU, but that requires us to really have load balancing, and that is informed on AI data, not just on memory, CPU, and VRAM usage. It's more about like who has more pre-filling for this request. I'm going to take it to that GPU because if you go to that GPU, just go and decode. If you go to the other GPU, you need to pre-fill and then decode.
Yeah.
So it's getting interesting. But the good thing is like once you build a good foundation and you really get into understanding these, and as you said earlier, you lock a few parameters and you focus on optimizing one of them, like cost or latency or throughput, you can iteratively go and improve. If you want to get them all improved at the same time, that's when you get overwhelmed. That's when you get like, oh my God, this like, there's like a new model, a new system, new framework, a new cloud AI GPU provider that does all of this.
A new way to quantize, a new way to
prune and distill. And it's like, and fine tune. I mean, at some point, also fine tuning. We were really actively thinking about it at the beginning to try to adapt our use cases to HR tech, but then we felt like it's going fine. Kind of foundational model are good enough to just do it without fine tuning. So quantizing was good to just scale it down, but nothing more. And then one of the other challenges that is becoming more and more serious is translations. Is supporting different languages. We are in a space where our customers are not just English speakers. We have 30-ish languages that we need to support. So which models do this the best? How do you do that? How can you manage this? And how can you even evaluate accuracy and quality of these responses?
Yeah, and you need a bigger model, bigger machines for models that can handle more of these.
More languages, yeah.
And talk to me a little bit more about how you're championing for the ROI of AI, because all of this is well and dandy.
Yeah.
But then if you can't prove that these AI generated summaries or polishing or any of that actually provides value to the customer, then it's like, cool, you just did a lot of engineering work to make this incredible for an engineer, but
not necessarily for the end user.
Yeah, the leadership is sitting there going like, so what?
Yeah. Again, this is part of things I get exposed to a lot. I'm not that kind of typical practitioner, in AI that is just focused with the terminals and like CLIs and all of that. I do that. But also I'm very business oriented, and I'm part of like a council internally at the company I work for, where we put together a vision and we try to assess where AI will have an impact. So when we started, building AI, we came up with this framework. I ended up calling it the flywheel framework, to be able to plan for where AI will help in terms of the product, and then with engineering and technical capabilities, go and build the first iterations of that. The third step is to really run it and look at how it's going. And then the fourth one that will connect you back to the planning is optimizing, which I was talking a lot about, like go and optimize, go and improve latency, accuracy, add support to other languages and stuff.
But that's the end of the whole flywheel. First, you have to understand if it's worth doing. And
so in the planning phase is where we meet across different departments. It's not just product and engineering deciding what we do, right? Like we work with our customer success, we work with our legal and ethical teams, we work with our sales. We really try to assess where AI can help us push the business forward. And when it comes to me and my contribution to the conversation is like, what is the easiest AI that we can build that can have the highest impact? I don't want to go and build like a 6 months, 9 months project and then find out that maybe, it was a big investment for a small ROI. I want to build the easiest thing that will really change the experience. So by collecting this information, work across these. And we have also customer councils. So we really work with our champions at our, because we are B2B. So we collect these information from our customers and we understand where do they think AI will help their end users, their employees. It's so funny because at the early ages of building AI, I mean, now we're talking about ages, but the early days of building AI, we had a lot of pushback on the adoption. There were a lot of concerns, lack of trust. Even the image of some of these AI vendors were not great because they were big customers, enterprise customers globally, were concerned about using their private data to train models. So they didn't really trust the systems early on. So they were...
Has that changed?
Completely changed. So they
don't care. They say train all my whatever.
Exactly.
If it's a better experience.
A lot of customers used to say, you know what? We don't want any data to go to any vendor. Mm-hmm. We don't want AI to be involved here because we don't trust these vendors. So that's our first push into building AI internally, self-host, self-manage. Our first early proof of concepts were through API-based AI, like OpenAI GPT. So we had to self-host, self-manage everything. So we can go back to these customers and say, hey, your data is private, is in the boundaries of our systems on the cloud. It's the same thing as saving your data into a relational database. Our AI will run within the ecosystem. But then what it changed like a year later is that the same customers, or most customers, are asking for our AI roadmap. They want to see where are we adding AI. They want to even contribute and push that roadmap towards what fits them best and what works for them. At some point, we had customers asking if they can bring their own AI. Like they have their own agents, or they have their own AI, or they have their own enterprise accounts within these vendors, and they want to connect that.
Oh, yeah.
Which is very interesting, and obviously something I'm open to consider. It's just, how can you make that system work where you don't control the model, you don't control, everything about it. It's just, you throw the data and you wish it's going to work. And you optimize. How would you optimize for that? Prompt engineering and all the work you do on a frequent basis, it's based on the idea that you know and control the models. If you don't anymore, that's going to be tricky. So where does the liability goes when it comes to the ownership and the issues and the problems with it? So yeah, it shifted completely from being very... I would say skeptical with AI and concerned about responsible AI and privacy, to completely the opposite. Like, we want more AI, show us AI, and we want AI to be here and here and here because it's going to save time. So all this leads back to that kind of planning phase where on a 2D kind of graph, you need to know what is the lowest kind of effort, technically speaking, to build the AI features or capabilities that will have the highest impact. Start there and keep it small in terms of scope and execution. So you don't want to spin up these huge projects and lose control in the middle.
And so you're mapping out on that 2D graph all the possible ways you can plug in AI. You've heard from customers, we want this feature, blah, blah, blah.
Yeah.
And then you're just kind of throwing story points at how
kind
long
of voting.
it would take?
Voting because at the end of the day, you and your team, from an engineering perspective, an AI team, will have to go and build it, right?
Yeah.
So you have to vote on, how much you think this is feasible. There's a lot of research that is involved, experimentation that is involved. Again, this space is moving so fast. So from an idea to turn that idea into really an execution plan, it's gonna require you to vote and chime into evaluating these requests. So yeah, when you end up with a view where you can have like a top right corner where you see what is high impact, low effort, that's where you kind of go and work and collaborate with the other teams on building. And also sometimes you think about the features or capabilities that will enable more capabilities later in the future. So this is where even my own thinking about building AI has been shifting over time, where I was trying to do more vertical AI. I'm going to do this AI capability for this domain. Think about like goal settings. As an individual who's working on a company, you want to build your own goals. Your OKRs, your whatever KPIs you have to track on a quarterly or yearly basis. But you don't want to build that on a silo for just yourself. You want to match this with your manager, your team, your department, or the top company goals. So building AI in any of this is for me a vertical AI, because we're just taking goals as a domain and kind of empowering with AI. Think about doing this in other domains, like giving feedback, like doing conversations between managers or 360 reviews. And now you have AI running in all of these systems. Now, if you have the right foundation, and if you build AI as a platform instead of a product, now you can build a horizontal AI, which can go and use all of these AI you build to build bigger, more complex, even multi-step AI, like building programs. You are someone who was promoted into a manager role. How would you manage your team in the 30, 60, 90 days? What meetings you need to set up? What data you need to collect about the people who are reporting to you now? if you had to do all of this without AI on your own, it's going to take forever. It's going to take a long time. But now with AI capabilities available in every one of these, it's going to bring to the surface a lot of good insights that another AI layer can really use to build a program for you across all of these. And now go and maybe suggest, okay, well, you need to set up goals this way for you and for your team. I recommend like you have a one-on-one on a bi-weekly. And maybe you need to start conversations with individuals. They report to you on 60 instead of 30. And maybe you need to kind of start to think about how would you develop skills for this team. Based on what we know about your team, you have gaps in certain things based on the goals you say. Like, again, I think of me of like managing a new team and trying to say, hey, like 6 months from now, we need to be able to have more advanced agentic workflows in the platform. But, AI would be looking at all of the feedback data or all of the skills that are in my team and figure out that I have gaps. So it's going to ask me to either develop gaps or find resources maybe from other teams to bring to this team so we can achieve that goal.
And this is like a deep research report on the team type of thing?
So it's more about using all of these AI capabilities within these verticals to build AI.
Yeah.
So you can call it deep research, but it's not built that way. It's more about, I would say, a workflow where you're pulling data from all of these systems and then trying to summarize this and then create insights and then go back and create actions within these domains.
And all of these verticalized ones, you're trying to create in a way that can be generalized. So you're using the same models.
Yep.
It's just that the product itself is vertical.
Yeah, exactly. It's all using, again, we're still in the mono model. But again, I think the future will hold this capabilities of like really tweaking every domain to the right size model, the right size architecture behind, because not every domain or feature require the same capabilities. I talked about this earlier. Generating content like goals is different from just polishing feedback or giving you a draft for a conversation.
Yeah, but all these verticalized pieces are then just bubbling up the most important parts to the prompt.
Yeah.
That is that horizontal layer.
Exactly. Yeah. And you know what? Another thing we have been also doing recently, which can lead to more tweaks and explorations in the infrastructure aspects or the MLOps aspect, is pre-processing these verticals before you come and ask for a horizontal feature.
Oh, nice.
Yeah. So if you can already generate a summary of employees' kind of goals or the feedback they received over the last year or so. So when the horizontal requests come to build a plan or build a whole program, this data is available. So you don't need to, on runtime, run AI and try to summarize and do all of that. You can have that data pre-processed. Where this works really well with the MLOps aspect is how can you do these batched work at a time where your AI is not requested the most. Yeah. Going back to what I was talking about, the scheduled, kind of scaling, if you can figure out these times where it's really low in usage and you have enough machines, you can run these batch job at night or a time where it's cheap.
Yeah, it's like consolidate learnings and then boom, you run that job, you kick it off. And...
Exactly. Yeah, and you have some sort of a queue of requests, pre-processing data, but it has a lower level of priority or urgency, so it can be done whenever there's a bandwidth to do it.
This now gives you that framework. You hit on how you choose the different pieces. Then you had that flywheel. There was the next step of going and building it.
Building is when you decide what is the best model, where is the best architecture, the architecture on the cloud, the cost and all of that.
You place some bets, and then you go and you optimize. That was the next.
And then you go and run it. So that's when you deploy it. Obviously, you have different stages before it goes to production, full exposure. You have it roll out into different stages and confirm that it's exactly what you want. And then you go and optimize. Once it's, again, deployed to production, you go and optimize and make sure, okay, well, this is good. But there's nothing we built in the last 3 years that we never went back and optimized. So that's the beauty of this kind of mindset of there's always opportunity, again, because in the last 3 years or 2 years, just the last 2 years, so many things changed. So many new models came up. So many new techniques to optimize the models came. So every once in a while, you go and change and optimize. And also internally, we had so many new requests to add to these. Again, support new languages, do it faster, do it better. Add more guardrails and safeguards, ensure that it doesn't do this, it doesn't do that. How would you also offline build an evaluation framework that will go and ensure whatever changes you do to the prompts or changing the models or the infrastructure, performance and accuracy and quality of these responses are still meeting a certain level that you have set up. So optimizing. I mean, if I had to draw this flywheel, like all the first three will be small parts of the circle. Optimization is at least half of it.
How do you know it's working? How do you know that the customer is finding value in it? Is it usage metrics? Is it?
Yeah. Well, I mean, it's usage metric. It's obviously another, you can also have reported data from the customer, self-reported data about their, think about an NPS score, right? Like how they think of this feature is changing the way they interact with the platform, or even with specific domains. You have also ways, because when we built all of this, we were focused on building responsible AI before anything, because we are an HR tech space, very highly compliant, regulated, very sensitive data all the time. Like I always get these questions about like data classification. I say everything is very sensitive. So it's one class.
Yeah.
So when you're trying to build the responsible AI, some of the pillars of responsible AI is transparency and explainability. So you need to be transparent about why AI did this, where this summary come from, what are the sources of data that are used to say that this person has this skill, as an example. And then explainability is sometimes when you do some of the AI changes or generation, you explain why AI thought that this is the best thing to do. So the way we think about AI is not just a tool where you can put your brain on the side and just use it. It's also something that will train your brain to do better next time, to grow as an individual or as an employee, and to develop skills as well. So it's a very good way to learn. So there is that. I mean, there is the reported data. We have ways to explain to the user how it works. We have also thumbs up, thumbs down, tell us if this doesn't meet your needs or it doesn't look good. And then we also collect a lot of metrics and data that we have internally to see how much the introduction of AI has changed the way people interact with the features and the product. So understanding that is our kind of promotional material, is to go and tell current customers and future customers, hey, using AI today, people are able to, we are able to achieve 50% more goal, metrics, or people are creating more conversations or giving more feedback because AI is helping a lot with that. You have the author's block. AI can build for you a draft without you to have to think so much about how to even start.
Yeah.
When you're trying to build goals, it's so hard for you to set your goals for the next quarter, the next year on your own. AI can really create drafts of goals for you that really, based on the history of all the goals you had, but also looking at your manager, your team, your department, and the vision of the company. So again, if I had to do this on my own, it might take a few days. Like we all been there, and we were asked to kind of put together some objectives and OKRs, and then find out where should I start? And you go and browse and look at everyone else to just make some decisions. Now AI gets you 80% there, and all you need to do is review, align, make sure you add anything that was missing, and creates this kind of a hierarchy of goals and objectives that before was really hard to achieve.
Are there any features that you put into production and you thought they were going to be successful? You were convinced that this is going to add so much value to the end user's life. We need to have it out there. And for some reason or other, it just didn't work, or it didn't work as you wanted.
Yeah, there's no direct path to success here. You had to go through iterations. And I think the most successful leaders and businesses just are the ones who had fewer scenarios like this. So one feature I recall is when you help users rephrase feedback they want to give to another person. And as a user, you will go and type your feedback the way you used to do it and use AI to just find any gaps in it, polish it, improve it. You might also go and give it bullet points instead of really develop your own feedback structure. And then AI will take that and improve it for you. And this is early on when we start building these kind of polish writing assist capabilities.
Yeah.
The challenge with these is the amount of things you need, the nuances and the language you use across different languages. That's even another problem. But the different nuances of how would you phrase these and how AI will take that and change it. Where, if you don't have the right setup for this, AI can take what you wrote and completely write a different version that will change it completely. Maybe it will have the same meaning, but completely in a different
and then users
way that doesn't look like you.
Yeah.
It's not your tone. It's not your language. So another thing that can do, again, hallucination is a big thing. It can start going into, different directions. It can start if that message is a little bit long, it can start to lose some facts in the conversation, and you have to bring it back to by tweaking it again and again. So I think this feature, when we first initially started, got the most feedback from the customers, where it's different. It's not exactly what I need, and I use it. I try it, and it gives me something that I'm not really interested in using, so I drop it. Mm-hmm. So usage is maybe high, by adoption is maybe low.
Yeah, value isn't there.
Yeah, so because we never go and push anything that AI writes on your behalf, you're still in control. AI is going to give you suggestion that you need to review and approve. So human in the loop is 100% guaranteed here. So what we have been doing since, and that kind of optimizing, is everything around guardrails and safeguards, and everything around adversarial testing. Go crazy and give it wrong feedbacks, and see how AI, because if you're, again, the whole idea here is to help you as an individual give the best feedback possible that is actionable and insightful. But if you are an upset employee and you're trying to give a feedback that is bad to someone else, AI should not empower that and give you longer versions of that, make it even worse. Yeah. So the guardrails had to be set up in a way that is like very dynamic. It has to learn over time. We had to learn from this feature, from the feedback, to keep improving it. So first time when you build this, you think, oh my God, I'm going to help so many users write great feedbacks. But then the feedback is like, oh, well, every time I use it, it doesn't look like a language I used, or it got into talking about things I didn't mean to say. So going back into that, and again, going back to the basics for me, every time we talk about these, is how you turn that into an AI platform, not just tweaks to that feature or to that product. How do you put safeguards and guardrails as part of the whole ecosystem, where you can tune it for this feature, but can use it for other features as well, and became part of the whole ecosystem.
Yeah, so you correct it once, and you don't have to go and correct it again every time it comes up.
And you have a structure to leverage this more and more in your next product. Yeah. So that's, again, that going back to the flywheel. When you go and plan maybe the next feature after optimizing this one, you already use all the knowledge you had and all the infrastructure you had. So that's one of the pitfalls I see, when people build AI, is you build these products in silos, and then you have to rebuild everything you have been doing. So one of the learnings I've had is, how can anything we do is a platform, is abstracted from these specific use cases, but more used as an architecture that can be spinned up for any other thing.
So let's shift from talking about AI products that you're creating for your company and your product to using AI internally, primarily on the engineering team. So agentic coding agents, agentic engineering, whatever the term du jour is. How are you guys doing that? How are you looking at the costs incurred there? Because that can be chaos. I was just at an agent bootcamp a few weeks ago, and folks were saying how they've created an internal dashboard on who's using what coding tools and how much they're spending, not because they want to tell someone don't spend, but they want to see, like, if somebody is spending a lot of money, they should probably talk to them and see what they're doing, how they're leveraging it, so that those people can then go and disseminate that information across the organization and showcase, like, how they're a power user.
So the first thing I recognized is how many options are out there and how fast these things are moving. And there's also a cultural shift, or maybe even a perception change. Software engineers, when they first learned about Devin as an example, the first AI engineer, we were all like, what? No way. This is like a joke. That's not going to work. I'm not saying it worked, but what I'm saying is, like, the perception early on was like, I'm not interested. This is not for us.
They did overpromise and underdeliver back in those days too.
Yeah, but the perception from software engineers and technical people were like, okay, there's no future where this will work. And then over time, again, with Cursor, with Windsurf, and with all of these capabilities and IDEs and AI, and then more recently, like, more focused on coding agents and stuff like that, perception has been changing. Mm-hmm. And for me, what I have been seeing is two curves. One is the adoption growing, for sure. Like, adoption of software engineers adopting AI technology is growing to certain degrees, where today, I don't have exact data, but internally in my team, I think we're close to 100%, if not 100%. I don't think we have any engineer who's not using AI. So I'm not going to assume it's 100%, but it's a very high percentage. And then the other thing is how that perception is changing. And even in that curve of perception, there were two sublines, I would say. And it depends on the seniority level. So junior engineers or early stage engineers have been more excited about AI. Why? Because they can do more with it. They can do things that used to take years for them to learn, and a lot of training and mentoring to get there, and exposure to bigger projects to do. So now a junior engineer is capable of spinning up an infrastructure, a full stack thing, and look at all of this and manage all of this without the proper training and exposure for it. And on the other hand, the most senior engineers, the architect level, they were very skeptical to how AI will help them. They are good, they're capable, they can do many things that others cannot do. So thinking about AI, they not only thought at the beginning AI will not change much in the way they work, but also they were concerned about other people, especially the less senior people, how they will use it. And that created the gap between, again, the output of AI versus, the perception and how we deal with it. So early on, when we started really exploring AI, I created what I ended up calling the AI Engineering Lab. So it's a space or it's a system where we can go all and explore AI with certain, limits to budget, obviously. And I mean, with the open source alone, you have a lot of exposure to a lot of good things. But internally, we adopted, a few tools that we start, offering seats to my team and go and explore. So with these things, with the AI Engineering Lab, I wanted everyone to go and explore AI without that kind of a predefined perception. I didn't want to dictate. I didn't want to say anything. I don't want the senior to influence the junior or vice versa. I want everyone to go and explore and use it in very limited scope to just ensure this is good. We start with some projects that were not very top priority, and we had people create code and use AI and go figure out these tools and bring GitHub Copilot mixed with a memory bank and very specific agents. And then I had my senior engineers, who were not like the most active in using AI on a daily basis, to kind of take a look and review this code. And I intentionally wanted them to give like a very honest feedback that doesn't know necessarily if this is done by AI or with the help of AI or not. And then definitely immediately they start seeing the patterns. They start to see that the quality is not great. The design patterns are not respected.
It has a smell to it.
It has a smell. Yeah. And I start having feedback that, hey, now that we opened explorations to AI, yes, it's off projects, all the side projects, not something that is critical path. But we are seeing a pattern of people using AI just to do more without taking that time saving to review and fix things and remove, anything that is not in our best practices. Sometimes AI will come up with its own design pattern while we have our own. We have components that we use that AI is not respecting and building its own component for UI or even for backend. So that is where the senior engineers got more and more involved into the process, saying, okay, definitely we have this problem. So I want the other people to take more time to review. So if AI is saving you 80% time or 70, use 20, 30, 40% of that time to review. So defining the new SDLC has been a process that we all contributed to. It was not dictated. It was not based on research. It was more like a collaboration within the engineering team, where we ended up fine-tuning over time what should be done. And the way we ended up adopting is like, use AI. Like we all agree now, AI is all over the place. But any time saving you do, use that to review AI. The output of your work with AI should be exactly the same as the output of your work without AI. Meaning you need to own the code, you need to understand the code, you need to really make sure it's adapted to our design patterns and our components. Otherwise, you're saving time by also creating a lot of problems that will either blow up now or later.
And did you take certain things from the senior engineers and immortalize them in like rules or ways that you can make the coding agents respect the components or the design patterns that are common practices within the org? Yeah,
so that's where, again, this AI Engineering Lab started the whole conversation and this is where I told you about the graphs, the lines earlier, where I think it started more with the mid-level engineers pushing to the adoption of AI, while the most senior engineers were like, okay, well, let's take our time. Let's be careful here. This can create a lot of trash.
Chaos in the database.
Yeah, and chaos. So now they have everyone's attention. I was like, okay, well, tell me more about this. And I had more time from the most senior engineers to go and review, to go get themselves also, spin up all of these tools and figure out the best. And what we ended up adopting is leveraging a lot of memory aspects, a lot of instruction skills based, where these agents, we go and build something that we all agree on, we vote on. It's like building code. Now, again, building these skills and these instructions, it's like writing your code. So you define what is best. You point the AI to the right kind of design patterns, to the right structures that it needs to follow. And then over time, the output of AI has been significantly changing, impacting the performance and velocity of everyone in the team, but especially the mid-level junior to mid-level.
Yeah.
So that's phase one of AI Engineering Lab. Phase two now is exploration beyond what we kind of started with, because as I told you, we started with junior and mid-level pushing more AI code, and then senior were like, okay, well, let me give you my attention here for a second. Let's improve this. Now everyone is using that level we got to, but now the push is coming from the senior, the most architect, kind of level people, where they're going exploring everything under the sun, Cloud Code and all of these things, and mostly CLIs, where it's changing the way they work. It's really a whole new way of writing code by managing all of these agents. It's not just one or two. It's like so many agents today, saving a lot of time for the most senior engineers, which again, at the beginning, they were very skeptical to the impact of this. And the same people that early on said, I'm not sure, I'm concerned, are now like, oh my God, I'm like a god.
Yeah,
it's like
they're running 8 different agents in parallel.
Yeah, they're using, at some point, they are outpacing our standards and our mechanism, because again, we have controls in the system. So they're spinning up their own personal machines, their own personal subscriptions to new systems, because they think it's going to take time for us to go and review security and legal, ensure like this is good. Like they are just experimenting outside of the regular kind of work, because they are so excited about this.
Yeah.
So at the end of the day, again, this AI Engineering Lab started to just open the conversation, and then kind of it took off from there.
They caught the bug.
Another thing we did is, when we spin up this whole thing, we did a survey to just have people report on AI impact on engineering. Because I don't want to introduce any DX tools like tracking, big brother way of like, are you using AI, how much you're spending, all of that. I mean, I have the spending, anything that is under the enterprise accounts, I have this spending, and we are keeping that under control. But the usage, the way you use it, I don't want to control any of that yet. And I wanted the people to just go and report on the data. So their own thinking about how AI is helping them. Do you think AI is helping you get better as a software engineer or get more as a software engineer? Because there's a difference here. If you are a mid-level engineer using AI, is that going to get you to senior earlier, or it's going to delay that because you don't have to think about the problems? AI is thinking about the problems. You're just delivering. So there's a difference between using AI to grow and be better, or using AI to just do more. Another thing I talked about earlier is is AI helping you to be a better engineer on your own, or a better engineer within a team? And is it making your team better? Is it making my whole engineering team better? So because there's a difference there. And if we didn't do this in a distributed way where everyone was contributing, and then feedback came in, and then we started with so many options, and then we got to a place where we have very few options that a lot of people agree on. If we didn't do that, the risk could have been of creating all of these silos of AI development, where everyone is using their own tool, everyone is spinning up something. Or we could have ended up with something that is dictated. Go and use XYZ IDE with these models. Your subscription is limited to this, and that's it. And you don't give freedom to the software engineers, and they will be just locked into that system.
With the AI inside of your product, you took a very opinionated approach, and you're optimizing to the max, and you're self-hosting. You're doing all these things that are very hard engineering-wise. With the AI being used on the engineering team, you're not really doing any of that. Yeah, and so do you foresee a world where eventually you're going to get to running your own Quinn or Kimi models for the teams, these coding agents that are self-hosted and you can completely rely on because of it's cheaper and it's better in that regard?
Well, that conversation is happening today. I've had people reaching out saying, hey, can we, now that we are deep into AI development and AI coding agents, can we spin up versions of our AI platform to support these efforts.
Yeah, because you were just talking about how you want to create a platform. So you've already got the primitives there, right?
Yeah. Well, that's the conversation we're having. As of now, the challenge is how to adapt that platform to be a development platform. So again, you need to go and pick the right models. You need to go and spin up the right way to support more and more agentic capabilities. We have been exploring many things like MCP as an example to just spin up not only the product, but also development. So there is a place where these two things will overlap a little bit, but that's where I need to go back to the flywheel and go and plan for it, go and build it and run it and then optimize. But definitely that's the direction. And as of today, I have conversations happening about leveraging our own platform to do our own AI coding.
And how are you looking at the cost for the AI coding?
Yeah. Well, cost is so far under control, which is surprising. We spin up these. I mean, we use different tools that the good thing about them is you have visibility into the cost and you can set up quotas.
Yeah.
And we were for a long time in this kind of experimentation stage where we use different models. And then even if these models were out of quota, we go to the next one and we try and we keep iterating. Now we are getting a little bit locked into what works the best. And this is where we're investing into enterprise relationship with these vendors and solutions and just adopt them at a bigger scale. But for a long time, I had my team exposed to different options, either led by the collaboration I have with our financial team just to get the number of seats I need, enterprise accounts, or just by exploring open source as well. I think there is a lot of opportunities with open source. And that's where the conversation was leading to this kind of leveraging our AI, because if we have the infrastructure, you can spin it in a different environment. But now you have less control on the sensitivity of the data in terms of like HR tag, the specific models. One of the examples I have here is, as an example, in our platform, we cannot use Chinese originated models as an example, like Qwen and DeepSeek. But for development, maybe we can. So that can create different options for us, less controls, because we're not serving HR tech anymore. We're serving software engineering. And for that, different requirements, different aspects that we can leverage our platform for. And yeah, that's going to impact significantly cost if we do follow that path.
And you can't use Chinese models because it's a stance that your company took, or it's a compliance thing?
It's a customer's request.
Yeah, I've heard a few people say that.
Yeah, so if you work with a global enterprise customers across the globe, again, this takes you back to the initial concerns we had with even OpenAI and Anthropic early on, because of how they, customers don't know what's the process to train the data. So that same thing is happening today with the Chinese-based models, where we don't know how the data is being trained. We don't, as customers. For me personally, I know how much these models are capable, right? I know what they're capable of, but the missing piece in AI sometimes is that, and I talk about this a lot, where it's all about the data at the end of the day. The data which we forget to talk about the most is the data that was used to train the foundation model. Yeah. Like we talk about the data for fine-tuning, we talk about the data for the prompts and in-context learning, but we miss that these models were trained with a certain corpus of data. So what is that data? What bias is in this data? So that kind of unknown is a no-go for customers. Yeah. And that's alone is a reason. And we had that same no-go for OpenAI, so I can really imagine this for Chinese. But I think perception will change over time, similar to that one. And there will be more competition, regardless of the source.
Too. Yeah. Well, I know, what is that company? Reflection. They got paid a bunch of money by NVIDIA just to create an open source lab in the US to rival the DeepSeek models. Exactly. Because people are asking for it.
Yeah. So customers are fine with the same capabilities model to DeepSeek, to Qwen, if it's trained in the US, if it has certain visibility into the training data. Yeah. So again, it's a more like a politics and legal aspects to things, but it's not, I won't say it stands from the company. It's more about the space we're in that is very highly regulated, compliancy, and the concerns about training and bias in general. Yeah. And there is a lot of also conversations to have with customers to explain how things work and how AI work. And the difference between using an open source model hosted, self-hosted, versus using their model through an API, so sending them the data. Yeah, explaining that. But the concern is more about the bias that is already in the models.